This video is going over part 2 of lesson 7.5, all on exponential functions. So in part 1 of this lesson, we went over graphing exponential functions, making a table, plotting it on a coordinate plane, and then our graph of an exponential function looks something like this, either going down or starting low here and going up, right? So if it goes down, it's exponential decay, it's going away, and if it goes up, from left to right, it's exponential growth. But the biggest takeaway is that it's not a straight line, right? Over time, since we're multiplying, since our x value is multiplying, or our y value, depending on x, it's slowly going to change, right? So here, it starts off going down, 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 and then it kind of tapers off, right? If it was growth, it starts off taper, just kind of slowly growing, and then all of a sudden, it starts growing really fast. Right? Decay is kind of the opposite. It's going down really, really fast, and then it kind of tapers off. Okay, so that's our exponential graph, what it looks like. If you see a graph that's doing something like that, it's kind of a curvy line, then you know that it's an exponential function that you're graphing. How can we tell if all we're looking at is a table, a set of data? Let me zoom in a little bit. All right, so look at our graph here. X is going to go up by a set amount, right? We're going to be adding x over and over. We're not multiplying x. So x here is going up by 2's, right? To get from one x to the next, I'm adding 2's. What we want to pay attention to is y. What is y doing? So am I adding or subtracting the same amount over and over? Right? Up here, I'm adding 2 over and over. Am I doing the same thing down here? Well, 64 to 32, I subtracted 32. 32 to 16, I subtracted 16. So it's different. I'm not subtracting or adding the same thing over and over. But I am multiplying by the same thing over and over, okay? Some people look at it as just multiplying. So we're looking at this as I multiplied it by 1/2. You can also think of it as division, right? I'm dividing by 2 over and over. So I believe the technical definition of exponential functions is that your y value is being multiplied over and over, right? Whether you're multiplying it by a number and it's going up, or you're multiplying it by a fraction and it's going down, right? I look at it as you're either multiplying or dividing. So when you're adding or subtracting over and over by the same amount, that makes a linear function. When you're multiplying or dividing by the same amount, that makes an exponential function. So here you could say we're multiplying by 1/2, or just say we're dividing by 2. 32 divided by 2 is 16. 16 divided by 2 is 8. Divided by 2 is 4. Divided by 2 is 2. We're dividing by the same thing over and over. So here we're dividing by 2. Up here we added 2. So since our y, and then x's are always going to be adding or subtracting, but the y's is what we want to pay attention to. So since we're dividing here, this is an exponent. This is data from an exponential function. Okay, so whether we're looking at the graph and we can see what it looks like, if it's a straight line, we know it's linear. If it's got this little tapered off curve, either going up or going down, then we know it's exponential. If we're looking at the data, we want to pay attention to the y values. So let's go down here and do some examples. All we have to do here is tell whether the set of data displays exponential behavior or not, right? You don't even have to say if it's linear or not. Just say yes or no, it's exponential. And then we have to show what we're multiplying or dividing by. Okay, so for our x values, they're all going up by 1. X is always adding or subtracting. Up 1, up 1, up 1. What is y doing? Are we adding or subtracting by the same amount? Well, let's look at what we did here. 5 times 2 is 10. If I multiply by 2 again, I should get 20. Oh, that's not what I got. Okay, so it's not that. 5 plus 5 is 10. If I add 5 again, I get 15. Yep, if I add 5. So it looks like I'm adding 5. Over and over. So no, this is not exponential. No. Why is it not exponential? Because our y values are increasing by 5. They're going up by 5 units. They're not being multiplied or divided. So our entire rate of change here, rate of change, our slope, is change in y over change in x. Our change in y, they're going up by 5. Change in x is going up by 1. So that's 5 over 1. Change in y over change in x. That's our slope. All right, so 5 over 1. If I have a slope, that's a continuous rate of change. It means it's a linear equation, right? Because it's going up, I'm adding 5 on the bottom. All right, next one. X is here again. We're adding 1 to get from one number to the next. On the bottom, what am I doing? From 3 to 9, I added 6. If I add 6, I should get 15. Oh, that doesn't work, so I'm not adding here. Well, what did I multiply 3 by to get 9? 3, right? So 3 times 3 is 9. If I do the same thing, 9 times 3, I get 27. Yep, 27 times 3 is 81. So we're multiplying by 3 over and over. And remember, the rule is if you're multiplying or dividing by the same thing over and over, it's exponential. So this is yes. And we're multiplying the bottom by 3. Multiplying y by 3. Okay, that's our explanation. All right, so for number 3, if we look at our x's here, here to here, we went up by 2. Here to here, we went up by 2. Here to here, we went up by 2. So we're adding the same thing over and over. On the bottom, what am I doing? Here to here, it looks like I divided by 2. 16 divided by 2 is 8, so I divided by 2 again. 8 divided by 2 is 4. So since I'm dividing by the same amount over and over, this is exponential. So yes, dividing y by 2. Why is it exponential? Because the y's are being divided by 2 over and over. Next one. So x, I'm adding 1 over and over. I don't even have to keep looking at that. I'm always going to be adding or subtracting by the same amount. Doesn't have to necessarily be 1. Like here it was 2, but I still was doing the same thing. I was adding 2 over and over. We want a constant rate of change in the y's, and then we're examining the x's. So this is going up by 1, great. These aren't going up by anything, right? So I guess you could say I'm multiplying by 1 over and over. Here to here, I multiplied by 1. Here to here, I multiplied by 1. Here to here, I multiplied by 1. So I am doing the same thing over and over here. So I could say absolutely this is exponential. Yes. Multiplying y by 1. If it was linear, it'd have to be going up or down by the same amount. It wouldn't stay the same. But when it's exponential, as long as I'm multiplying or dividing by the same amount over and over in the y's, and here I'm multiplying by 1, 3 times 1 is 3, 3 times 1 is 3, 3 times 1 is 3, 3 times 1 is 3. Number 5. Here I'm going up by 5s on the x on the top. So I'm going up by the same amount. I'm adding 5 over and over. On the bottom, it looks like I'm dividing by 2. 1 divided by 2 is 0.5. 0.5 divided by 2 is 0.25. 0.25 divided by 2 is 0.125. So I am dividing by the same amount over and over, or you could think of it as multiplying by 1/2. So we're going to say, yes, this is exponential. Dividing y by 2. And I'll just write it down here. Or multiplying by 1/2. Oops. Hey, side note too, it's the same. So if I did something divided by 6, right? Dividing by 6 is the same thing as multiplying by 1/6, right? Dividing by 8 is the same thing as multiplying by 1/8. It's the same thing. Dividing by 2 is the same thing as multiplying by 1/2. So just FYI, keep that in the back of your mind. It doesn't really matter which way you look at it, but on a test, if it says, what are you multiplying by? And you're like, I'm not multiplying, I'm dividing. Well, dividing by 2 is the same thing as multiplying by 1/2. Whatever number you're dividing by goes on the bottom of the fraction you're multiplying by. FYI. All right, and then last one here, last example for this lesson, number 6. X is going up by 1, great. Y, it looks like I'm multiplying by 1/3. 1/3 times 1/3 is 1/9. So I'm multiplying by 1/3. 1/9 times 1/3 is 1/27. So again, I'm multiplying by 1/3. 1/27 times 1/3, don't forget when you multiply fractions, straight across the top, straight across the bottom, that'd be 1/81, which is what I got. So I multiply this guy. And 1/81 times 3. So since I'm multiplying by 1/3 over and over, you could also say that's dividing by 3 over and over, right? Same thing. Remember down here we talked about it. Dividing by a number is the same thing as multiplying by 1 over that number. So if I'm multiplying by 1/3, same thing as dividing by 3. So we'll say, yes, this is exponential because I'm multiplying y by 3, or you could say, or dividing by, wait, I'm multiplying by 1/3, sorry. I'm multiplying by 1/3 or dividing by 3. All right, so biggest takeaway here for exponential functions, I'm always gonna be adding or subtracting by the same amount for x. I wanna keep everything steady. Whether it's 2, 5, 1, whatever, I'm gonna be adding or subtracting. But in the y's, if it's a linear equation, I'll be adding or subtracting by the same amount over and over. If it's exponential, I'm gonna be multiplying or dividing by the same thing over and over. And if it's just gibberish, if there's no pattern, multiplying or adding or whatever, then it's nothing. But it definitely would not be exponential. To be exponential, you gotta multiply or divide the y's by the same amount. All right, let me know if you have questions.